These are logarithms. When you first encounter them, they probably look scary. But in this video, I'm going to teach you that they aren't so bad. We'll go over what logarithms are and how to solve them. So let's begin. The logarithm is a function. It's like sine or cosine. You input a number and it outputs another number. Let's take a closer look. We have three parts: the base, argument, and exponent. So, when we use the logarithm, we're basically asking ourselves, I should raise the base to what number to get the argument? To make this clearer, look at this example. It's read as log base 10 of 100. So, I'm going to ask myself, I should raise 10 to what number to get 100? Well, 10 squared is 100. So I know that I need to raise 10 to 2 to get 100. And so our answer is 2. That was a simple example, but sometimes the expressions are a bit more complex and we'll need to know how to evaluate them. And that's why we have our rules of log. Let's start with the first rule, the logarithm of 1. Log base b of 1 is always equal to 0, because if you raise any number to 0, it ends up as 1. The next rule is the log of the same number as the base. So log base b of b is simply 1, because you just need to raise the base to 1 to get the base. Next, we have our product rule. So if we have log base b of m plus log base b of n, you can simplify that to become one logarithm, so log base b of m times n. Similarly, our quotient rule says that if you have log base b of m minus log base b of n, then you can also simplify this to one expression, this time giving you log base b of m over n. Now, the power rule. If you have log base b of m to the n, you can actually pull out the exponent of m to be a coefficient. So this becomes n log base b of m. Now, what about if you have a number raised to a logarithm? So for example, you have b raised to log base b of x. Well, this is actually simply equal to x. Finally, we have our change of base rule. We want to use this when we want to change the base of our logarithm. So, log base a of b is simply equal to log base c, which is our new base, of b, all over log base c of a. Another thing to note is that logarithms are just the inverse function to exponents, okay? So it's just another way of writing exponents. And so we can actually transform logarithms into exponents. So how do we do that? How I like to remember it is you simply switch around these two numbers, the argument and the exponent, and then just remove the log. And that's basically it. And so if we have, for example, log base b of a is equal to c, then you switch these around and you get b to the c is equal to a. So now that we know the basics of what logarithms are and how to solve these logarithms, let's try doing a few examples to solidify our understanding. Let's start with a straightforward and easy evaluation example. So here we want to find out log base 10 of 50 minus log base 10 of 5. Okay? Intuitively, you don't really know how to evaluate these without a calculator. Like, if we want to know what number to raise 10 to get 50, it's quite difficult. So we can make use of the laws that we just learned. This looks like the quotient rule. So we can write this as one logarithm, log base 10 of 50, okay, 50 over 5, which is simply log base 10 of 10. And we know that in order to get 10, we simply need to raise 10 to 1, right? And so our answer for this would be 1. Let's try another example. Here we want to find out log base 4 of 8. Again, intuitively, a bit difficult without a calculator, but we can make use of our change of base formula, right? So if we want our base to be 2, which I feel like would be easy, we know that our log base 4 of 8 is simply equal to log base 2. Now remember, I just chose this base as our new base, okay? So it's log base 2 of 8 all over log base 2 again of 4, right? Now this looks much easier. 2 raised to what would give me 8? I know that 2 raised to 3 would give me 8, and so our numerator would be 3. And now 2 raised to what would give me 4? That's simply 2 squared, right? So this would give me 3 over 2, and that is our answer. Finally, you can even use logarithms to solve some algebra, right? Some algebraic equations. So again, as I've said, you can switch around these two to make it exponential, right? So you switch around these two, you remove the log, so you end up with, okay, 3 squared is equal to 2x plus 1. Simplifying this, we get 9 is equal to 2x plus 1. You minus 1 on both sides, and you end up with 8 is equal to 2x. Divide 2 on both sides, you get 4 is equal to x. And this is your final answer. So hopefully now you've realized that logarithms aren't too bad. Yes, if you're given really complex equations, then you'll have to simplify lots of things. But at the same time, with practice, I'm sure you guys can get it.